Alright, 8th graders. Today we're talking about squares, roots, cubes, and rational numbers. And the first thing we're going to do is make a list of the perfect squares. The perfect squares are 1 squared, which is 1, 2 squared, which is 2 times 2, which is 4. 3 squared would be 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. So this whole lesson is essentially the types of questions that you will see on EOG and EOC. This would be 8th grade and EOC, Math 1. So it's really important because it'll be on both. But I think it's all kind of common sense math, and I think it won't be so bad. So the square root of 40 is between what two perfect squares? So here we see the perfect squares are 1, 4, 9, 16, 25, 36, 49. We can see that 40 is in between 36 and 49. So the square root of 40 is in between the perfect squares 36 and 49. You're going to have to pay really close attention to this because the next question seems like a similar question, but it's going to have a different answer. The square root of 110 is closest to what integer value? This question could have said the square root of 110 is in between what two integers, in which case they would be talking about in between 10 and 11. And then on number 2, if this instead of perfect squares said between what two integers, it would be between 6 and 7. Does that make sense? Alright, so the square root of 110 is closest to what integer value? Is it closest to 100 or 121? Tiago? It's closest to 100. So what integer value is it closest to? You can shout it out. 10. Negative square root of 50 is closest to what integer value? So we're going to look at the square root of 50 is closest to 49. But because it's negative, we're going to say what for our answer? Negative 7. Alright, and number 5. Negative 150 is between what two perfect squares? Negative 150 is between what two perfect squares? So the negative 150 would be here between, negative 12 and negative 13. But they're asking for the perfect squares, so we want to say 144 and 169. Alright, number 6. What is the smallest integer value of x if the square root of 20 is less than x. So these questions are super annoying because they're worded terribly. The smallest integer value of x if the square root of 20 is less than x. I would first rewrite this as x is greater than the square root of 20. I would flip it around and say x is greater than the square root of 20. What is the smallest value of x? Hannah?
4.
Okay, so let's see if that makes sense. 4 is greater than square root of 20. So what would you change your mind to?
5.
5. The smallest integer value that we could pick is 5 is greater than the square root of 20 because 5 is just the square root of 25. And that's the smallest integer that's greater than the square root of 20. What is the smallest integer value of x if negative square root of 120 is less than x? Again, I would change this to x is greater than negative square root of 120. And if you go back in your list, 120 is closest to what? 11 squared, which is 121, right? So, can 11 go here? 11 is greater than negative square root of 120.
Yes. Yes.
Negative.
No.
But we're talking about negatives. So
Negative 10.
negative 10 is greater than negative 120. Does that make sense? Because we're dealing with negatives. If you think about your number line, negative 11, this was almost negative 11, the negative square root of 120. So the greater number would be here. Yeah. Find out what x equals.
In the greater value.
Uh-huh. Alright, circle all of the irrational numbers. So let's do a quick review about irrational numbers. Irrational numbers never end. And never repeat. The most famous irrational number is, of course, pi. So anything with pi in it is irrational, no matter what. Okay? Now, tell me some of the things in here that never end and never repeat. Tell me the obvious ones, the ones that make perfect sense. Colin, tell me one.
14.6132.
That's not repeating, and those ... is telling me that it's going to go on forever. Alexis?
3.3 repeated.
You just said it.
What?
You said 3.3 repeating. So that 3 is repeating, so does it fit our criteria?
Wow.
Right? No, everybody makes this mistake. Okay, so let's look. Here's the deal with square roots, though. Square roots, of course, are going to play a part in this. The square root of 10, so anything that's not a perfect square never ends and never repeats when you take the square root of it. So is 200 a perfect square?
No.
If I go back to my list, 200 is not a perfect square. We go from 196 to 225, correct? So the square root of 200 will never end and never repeat. Let's look at this one over here. Is 9 a perfect square and is 100 a perfect square? Are they both perfect squares?
Yes.
They're both perfect squares. Square root of 9 is 3, square root of 100 is 10. So this is just 3/10. So that's rational. This one ends up repeating down here, right? So that's rational. This decimal ends, it's just -10, so that's rational. 7, it ends, it's rational. The square root of 10 and the square root of 25, are those both perfect squares?
Not the 10.
10 is not a perfect square, which will make this whole thing irrational. Only square roots that are perfect squares are rational. Now, the cube root of 81, that's, instead of a square root, that's saying what 3 numbers multiply together by themselves to make 81. So I would go through my list. I would say, okay, 2 times 2 times 2 is 8. 3 times 3 is 9 times 3 is 27, so it's not 3. 4 times 4 is 16 times 4 is 64. 5 times 5 is 25 times 5 is 125. Is that going to be rational or irrational? Is it a perfect cube? It's not a perfect cube, so it's going to be irrational.
So the 3 same numbers have to equal 81.
Yes, for it to be a perfect cube. Just like the 2 same numbers have to be for a perfect square, 3 numbers that are the same have to be a perfect cube. Yes.
So the top and the bottom on the fraction and the perfect square both have to...
They both have to be perfect squares. If one of them's not a perfect square, like on 10/25, then it doesn't count as a perfect square.
So it's irrational.
It's irrational. Alright, which number is a perfect cube and a perfect square? So, first let's check all of these. Are each of these perfect squares? 100 is a perfect square, 10 times 10, right? But is there anything that multiplies by itself 3 times to make 100? No. 16 is 4 times 4, but is there anything? The only thing that could multiply possibly to be 16 would be 2 times 2 times 2, but that's 8, so it's not that one. 729. So these bigger ones are not perfect squares that you would be expected to know. So I would use a calculator. Square root of 729 is 27. 27 times 27 gives me 729. And then the cube root is also able to be done on the calculator. On the classroom calculators, you type in the 3 first, and then you know the caret button that you use to make exponents? Right above it is the x square root. So you type in the 3 second square root, and you end up with the cube root. And when you type in 729, you get 9. So 9 times 9 times 9 is 729. So 729 is our perfect square and perfect cube. That should be calculator active type of a question, but there are no guarantees. If that were the case, the only thing that I know to tell you, especially for the cubes, is to go through and say 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 9 times 3 is 27, 4 times 4 times 4 is 64. And they get high pretty quickly, right? I mean, it wouldn't take you super long to get to 9 to know that that was a perfect cube, but it wouldn't be the most fun you ever had. Alright, what is the largest integer that is less than the square root of 30? So I would go back to my original list and say Okay, square root of 30 is between 5 and 6. And I'm looking for the largest integer that is less than 30. So, Roan, you're correct. It is 5 because the square root of 25 gives me 5. And that's the square root that's just below the square root of 30. Alright, number 11. If m equals the square root of 200 and n equals the square root of 100 and m and n are rounded to the nearest integer, what is the value of m minus n? Alright, so the square root of 200, I have to round to the nearest integer. I know 14 squared is 196. And 15 squared is 225. So what's the nearest integer to the square root of 200? What's the nearest integer, Lil? 14.
Yeah.
So m, we're going to say equals 14. And the nearest integer to the square root of 100 is the actual answer, which would be 10. N equals 10. So now, what is the value of m minus n? 14 minus 10 would give me 4. Which values make the following problem true? Square root of j minus... Okay, which of the values make the following problem true? The square root of j minus the square root of b equals the square root of z. So, I'm just going to fill these in. The square root of 25 is 5. The square root of 4 is 2. And the square root of 9 is 3. Oh, lucky us, the first one is true. Alright, and then the last thing that we have to do, order from least to greatest. So, 4 is the obvious one. That one's good. Pi, we know, approximates to what number? 3.14. The square root of 8. So the square root of 8 is almost, it's really close to what perfect square? It's really close to what perfect square?
3.
Yeah, it's close to 3. It's almost 3. So I would put that down for like a 2.9 if we're approximating, because the square root of 9 is 3, so the square root of 8 is close to 3. And then the cube root of 25, like I said, the cube roots, the best thing to do is say, okay, I know 3 times 3 times 3 is 27. And 25 is close to that. So I would say this is another like 2.9 situation. We're close to 25. And then on the next one, the square root of 100 is 10. The square root of 4 is 2, so that just equals 5. And then we have 4. Now, these two right here, I would think on the EOG we would not have something that would be that close to each other. I'm going to use my calculator and just find out what the actual approximations are.
Square root of 8 is 2.8.
The square root of 8 is 2.8 and the cube root of 25 is 2.9. So we'll go with that. So least to greatest would be, now you have to put them back in their original form. Don't go writing these decimals down. It'll be wrong. So square root of 8, cube root of 25, pi, 4, and square root of 100 over 4 would be least to greatest. On 14, this is one of my favorite problems. You know how I'm strange in like math problems. So the sum of all integers between the square root of 30 and the square root of 111. So the next perfect square would be the square root of 36. And so then we're going to write down all the perfect squares. So 6 times 6 is 36, 7 times 7 is 49, 8 times 8, 9 times 9, 10 times 10, and then 11 times 11 would be too far, right? It would be above that. So the integers between those two numbers are 6, 7, 8, 9, and 10. And we're going to add those together because it says the sum of all of them. And I get 19 plus 8 is 27, plus 7 is 34, plus 6 is 40. And that's it for your notes videos. Have a great night.
Yeah.
Oh, wait. I forgot. Thank you to my class for letting me record.
I look so pretty.